Hello, students. So this is the What Comes Next activity from Desmos, and I just wanted to go through a couple slides here and talk about a few things I notice. The first thing that I notice here is just it's asking us to follow a pattern and drag the black dot to show your prediction for what comes next. If I'm just eyeballing it, the dot looks like it would be kind of right about there. And the reason that makes sense to me is because if I just sort of visualize this line, it goes right through there. Now, if I wanted to be more precise than eyeballing it, I can actually count on the grid. And I'll notice that to get from one dot to the next, I'm going up 2 over 3, like this, up 2 over 3. And so repeatedly going up 2 over 3 again. So pretty close to where I eyeballed it. So the nice thing about lines is you can always predict what comes next on a line by counting how far up and how far over, like a staircase. And that's, of course, the concept of slope that we talked about over and over again. And so I would just say the slope is 2/3 because it goes up 2 and over 3 repeatedly. All right, so moving on to the next slide here. This one here kind of also looks linear. If I draw my line through it, it seems to go there. And this goes down a half box and over 2, and down a half and over 2, and down a half and over 2 would put the dot right there. So let's put that right there like this. And, visually it's going down a half and over 2. But I don't actually want to write that because if I look at what the y values are actually, the y values aren't going down by a half. So you got to be careful when you have one of these graphs and like, what is the scale here? And I want you to notice, let me clear the screen so you can see a little easier, that it's 4 boxes up is equal to 8. 4 boxes is equal to 8 on the y value. So maybe I'll just say 4y equals 8. Dividing by 4 means that each of my y boxes counts by 2. So be careful. When we were working on this activity, I saw a lot of people wrote that the slope was negative 0.5 over 2, which I understand what you mean visually, but when you look at the actual numbers that are being used, it's not going down by a half. It's going down by 1. Again, the way you can do that on Desmos is you just click on those dots, and you can see the y value is dropping by 1, the x value is increasing by 2. So that's a slope of negative a half. Now looking at this one here, I can kind of eyeball a line and then, oh crap, that dot's not on the line. And same thing, if I try to eyeball a line between these two dots, it doesn't fit on the first dot. So this is clearly not a linear pattern. Now in the real world, there's obviously lots of different types of patterns, but within this unit right now, I want you to just be always thinking, is it linear or is it exponential? So for the next week or so in class and when you're doing this activity, it's either linear or it's exponential. That's what we're comparing and contrasting. And so because I couldn't connect the dots with the line, it's not linear. So it needs to be exponential. So if we think about exponential, we should be thinking about what number is multiplying or dividing to move us from one y value to the next. Y value of 2, y value of 4, y value of 8. And thinking about what dot can I put, where can I put the black dot to fit it in with the other ones? And I would argue that the dot needs to go right here at y equals 1. The reason it needs to go where y equals 1 is because then I have a clear pattern where my y values are, if I go to the left, the y values are multiplying by 2. If I go to the right, the y values are dividing by 2. So for this one, I would say my m is 1/2. Those parentheses are not necessary. I actually just erase them, but when we write our exponential equation, we put parentheses around the m, so that's why I kind of did that there. So notice that, again, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. Each time I'm multiplying by 2 if I went from the right to the left. But when we read, we go from left to right, and that's why I wrote 1/2, because that is 8 times a half is 4, 4 times a half is 2, 2 times a half is 1, etc. Here, again, it's not linear. I hope you can see that visually, that this is not a linear pattern. And if I look at the 3 different y values that are given to me, I can see that There's no consistent adding. It's not like I can add the same amount to get from one to the other, so it's not linear. But there is a consistent multiplying. In fact, these are all multiplying by 3. And I know that just because this first one, if I click on it, this first dot here, that's 1/3 written as a decimal. 1/3 times 3 is 1. 1 times 3 is 3. So the next dot goes up here at 9. Notice I put it at a half box because, again, like I talked about just a few minutes ago, 8 is 4 boxes up. And so each box counts for 2. So this is an m equals 3 pattern because the common factor is 3. It's multiplying by 3 each time. Now, when I look at this right here, many of my students got this one wrong. So I have 2 dots here, and many of my students, many of you just did this and said, I know that the third dot is right there. And that is one possibility, but that is not the only possibility. We have a height of 2, we have a height of 4. One possible third height is 6. A second possible third height is 8. And both of those values are reached by having m equal 2. So how can we get 2 different answers if we have the same m value? It's because we can have a linear m, or we can have an exponential m like this. The 2 different patterns that we can have, and actually I'll use different colors here. I'll do blue for linear. If we have a linear pattern, we have y equals 2 plus 2x over 2, because it has a y-intercept of 2, and it goes up 2 boxes and over 2 boxes. Whereas if we did an exponential pattern, it would curve like this, and that would be y equals 2 times 2 raised to the x over 2. So what is the answer to the question here? Megan is correct. We do not have enough information to determine what the next point is. 2 dots could be linear. 2 dots could be exponential. They could be some other pattern that we don't know about. I'm going to speed through just a couple more slides here. Here, this is a linear pattern. The y value is going up by 2, so the next number is 7. Here, this is a linear pattern. The y value is going down by 3, so the next value is -1. Here, this is not linear because the y value goes down by 8, then down by 4. So I know it's not linear. And again, within this activity and within this unit, just be thinking about either linear or exponential. This is, again, times by a half pattern. So our next number is going to be 2 because that is half of 4. Looking just a couple more slides here, and then we're going to call it good. This one's a little bit trickier. I hope we can tell it's not linear because this was plus 10 here, and this is not plus 10. 1/3 plus 10 is not 2. So I know it's exponential. And the way you can find the exponential multiplier is by taking 2 consecutive y values and dividing them. 2 y values that are next to each other. So I just did 12 divided by 2, and that turns out to be 6. To check my answer, I can take 2 divided by 1/3, and you'll also get 6. And that makes sense. If you think about how many times you have to add 1/3 until you get 2, it takes 6 of them. If you have 2 whole pies and you cut them into thirds each, you get 6 slices of pie. So I know that my multiplier is 6, and that means my missing number is 6 times 12, which is 72. Let's just look at one more slide here. Abby and Megan again talking to each other. And I want you to notice this is the same exact situation, just where we're given the numbers instead of the graph. This could either be a +3 pattern, in which case my third number would be 9, or this could be a ×2 pattern, in which case my third number would be 12. So we don't know. Megan is correct here. So I really encourage you to make sure you finish the rest of the activity. Go back and do all of those again. You got to know how to do all of these, thinking about if the pattern is a consistent add or subtract pattern, that's linear. If it's consistent multiply or divide, that's exponential. Remember that our exponential functions can be written like this, and our linear functions can be written like this. Thank you. Let me know if you got any questions.